In this video, we will discuss about cumulative distribution function of Weibull distribution. Cumulative distribution function CDF of Weibull distribution. Distribution. So we know the PDF of Weibull distribution. So now we are going to obtain the CDF of Weibull distribution. So we obtain the CDF of Weibull distribution on the basis of two parameters. So now we write down the PDF. So the PDF of Weibull distribution for two parameter is fx. Fx is equal to beta upon eta x upon eta raised to the power beta minus 1 into e raised to the power minus x upon eta raised to the power beta. So this is the PDF of Weibull distribution for two parameters where both parameters are positive and x is also positive. So now we are going to solve the CDF of Weibull distribution. So the CDF, so we write down the CDF of Weibull distribution. The CDF of Weibull distribution, CDF we denoted as capital Fx, which is equal to probability of random variable x have less than equal to x. So now this we can obtain as integration 0 to x into ft dt. Okay, because we are taking the limit in terms of x, so then we function change into the form of t. So we write down ft into dt. So here this is fx. So now function x we convert into the form of t. So then this can be written as, so this is equal to integration 0 to x, the ft. So we write down as beta upon eta x upon eta raised to the power beta minus 1 into x, sorry, x changed by t. So here we replace x by t. So this can be t upon eta into e raised to the power minus t upon eta raised to the power beta into dt. Is the power beta into dt. So now when we evaluate this integral, so we use the substitution. So this we can solve by using let t upon eta raised to the power beta is equal to y. So we consider this as y. So now we write down this as t upon eta. So this can be written to y raised to the power 1 upon beta. So now what is the value of t? The value of t is eta y raised to the power 1 upon beta. So now we calculate the value of dt. So what is the value of dt when we differentiate separately? So this gives us 1 upon beta, 1 upon beta into y raised to the power 1 upon beta minus 1 into dy. So we write down the limits. So what are the limits for this? So for lower limit, so we write down the limits. So for lower limit, sorry, for lower limit, so here we are going to write lower limits. So for lower limit, we have limits are x. So that means here we take as t. t is equal to 0. So this is t equal to 0. So for t equal to 0, what is the limit for y? So that means t upon eta raised to the power beta is equal to y. So when we put t equal to 0, so this gives us 0 equal to y, means lower limit is y equal to 0. Now when we obtain the upper limit, for upper limit, so when we calculate the upper limit means t is equal to x. So for t is equal to x, so when we put t equal to x in this, so x upon eta raised to the power beta is equal to y. So this is our lower limit. So y is equal to x upon eta raised to the power beta. So the limits are for y. So then we write down the limits for y equal to 0 to y equal to x upon eta raised to the power beta. So x upon eta raised to the power beta. So we write down x upon eta raised to the power beta into, we put the function. So first is constant beta upon eta. So we write down first term beta upon eta. Then we write down the second term. Here is t upon eta raised to the power beta minus 1. T upon eta raised to the power beta minus 1. So we do the rough work here. So t upon eta raised to the power beta minus 1. So this can be written as t upon eta raised to the power beta into t upon eta raised to the power minus 1. So this t upon eta raised to the power beta, we have considered this is equal to y. So this we have write down as y. Now this we can write down as, so this we can write down as the t upon eta. What is the value of t upon eta? So the value of t upon eta is y raised to the power 1 upon beta. The value of this is y raised to the power 1 upon beta and raised to the power minus 1. So this can be written as y into y raised to the power minus 1 upon beta. Okay. So you can write down this as y raised to the power 1 minus 1 upon beta. So 1 minus 1 upon beta. So now here we write down this as y raised to the power 1 minus 1 upon beta. Now what is the next term? Next term is e raised to the power minus. So next term is e raised to the power minus t upon eta raised to the power theta. So this we have considered as y into dy. So what is the value of dy? Dy means dt. Sorry. What is the value of dt? So dt value is eta upon beta. So dt value is eta upon beta. Eta upon beta into y raised to the power 1 upon beta minus 1 into dy. So this is the value of dt. Okay, so this is the value of dt. Now we simplify this. So when we are going to simplify, so this is we can write down integration y is equal to 0 to x upon eta raised to the power beta. So this eta to eta cancelled, beta to beta cancelled. Eta can take outside the integration. So and we write down e raised to the power minus y into here. We have base is same. So we add the powers. So this can be written as 1 minus 1 upon beta or plus 1 upon beta minus 1 into dy. So 1 to 1 cancelled, 1y beta to 1y beta cancelled. This gives us y raised to the power 0. And y raised to the power 0 gives us 1. So this can be written as x upon eta raised to the power beta into e raised to the power minus y into dy. Okay, so this you can write down this equal to y raised to the power 0 equal to 1. So we integrate this e raised to the power minus y. So what is the integration of e raised to the power minus y is minus e raised to the power minus y into 0. And this can be written as x upon eta raised to the power beta. So when we apply the upper limits, this gives us minus e raised to the power minus x upon eta raised to the power beta or minus minus plus lower limit e raised to the power 0. So what is the value of e raised to the power 0? So the value of e raised to the power 0 is 1. So this can be written as 1 minus e raised to the power minus x upon eta raised to the power beta. So this is the CDF. So this is the CDF of Weibull distribution. So this is the value of fx. So value of fx is this. So we have a CDF. This is the CDF. This is the CDF of Weibull distribution.